All right, good evening, everyone, and welcome back to class. Remember, if it's your first time here, do well to subscribe to our channel, like this video, and leave a comment if you find it very interesting. So, in this class, we are going to be looking at the continuation of our working subtopic. I'm talking about statistical analysis right here in Microsoft Excel. Okay, now for those of us who are not very familiar with some of all these statistical tools, I'm going to take some time to explain them. Now, if you look at the data we have right on the screen, you can see OGB 1, 2, 3, 4, 5. So these are records from water samples collected at different points for a study I was working on. So these are water samples, that is parameters, physicochemical parameters for 8 water samples collected at different locations in an area. And you can see the last column here is the standard limits, which is WHO standard limits, okay? So this is going to serve like a control for us to know if the parameter for each of these sample stations are in line with standard limits or they are falling short. All right, so you can see the parameters being tested are here from 1 to 17 parameters. All right, now what we need to find out first is there a relationship between each of these parameters and the standard limits, okay? If the ANOVA is simply analysis of variance. So analysis of variance is a statistical tool used to analyze 3 or more data sets, 3 or more. So for you to apply ANOVA, the variables you analyze must be at least 3. So you see we have 1 to 8. So it satisfies the condition for ANOVA. And remember, we are analyzing it with respect to the standard limits, okay? So we want to find out if there's a relationship between these variables. Are they all the same or are some varying away from the standard limits? So remember, you have to activate your data analysis. I'm going to show you how to do that again. You go from File, go to Options, then you click on Add-ins. Now here you see as Excel add-ins, you click on Go. Make sure that each of the add-ins available are all ticked. They are all marked good. Then you okay. If you do that successfully, you're going to see the data analysis button is going to be out right here. And that is now what we're going to use to conduct this analysis of variance. Now, I'm not saying it is only used for water quality analysis. Think of it like sales from 3 different branches of a company with respect to some products. I want to find out, is the sale all equivalent? Are all branches making equivalent amount of sale? Or is there disparity or significant difference between the sales in these branches? All right, so that's what ANOVA tries to check. This is just a case study here. So I'm going to conduct ANOVA on this. Shortly, we will be doing t-test, which only compares only 2 variables. All right, so from data, I will click on data analysis. If I scroll up, the very first one is ANOVA single factor. Yes, I'm going to choose that. And okay. Now in this dialog box, it's just asking me to enter my input range. Remember, I just want to check if there's difference between the sample stations, not only the parameters. So I will highlight the parameters, including WHO standard. All right, now having done that successfully, now Excel is asking me how my grouping is by column. You can see columns here. And then please, label should be in the first row. So where you have OGB 1, 2, 3 should be the label. Now this alpha value is called level of significance. It's a statistical parameter. It can be 0.01, which is 1%, or 0.05. But by default, it is 5%, which is 0.05. So you don't need to touch that. Now I need my outputs to display in a new sheet, as of course. Then I'll click on OK. Now we have the output here. You can see the summary table. Excel has been able to compute the count, the sum, the average, and variance of each of these parameters. Away from that, this is now the output results, which we're going to learn how to interpret in details in subsequent class. Now look at this output results here. You have between group, within group. Look at these values here. Now we have the F and the F critical. So the F is the computed ANOVA value, while the F critical is the one from the statistical table. So the rule is reject the null hypothesis if F calculated is greater than F critical. What do I mean? The F calculated is 0.42 and the F critical is 2.0. So that condition does not hold. It simply means that there is no significant difference between the performance of each of these parameters tested across the 8 water samples, and as well as compared to WHO standard. Okay. Now another way to check that is if you use the p-value. You can see the p-value here is 0.9, which is insignificant. So p-value less than 0.05 is equal to significant. Why p-value p-value greater than 0.05 is considered insignificant. So this test is not significant. And by implication, what does it mean? It simply means that there is no significant difference between the physicochemical parameters of these water samples collected at all these locations. It means that they are all in line with WHO standard. Okay, so when your test fails, it means there is no difference. Okay, but if the test is significant, it means there is significant. At least one of the data points is different. Now let me show you a situation where we can have such significant tests. Let me say I just change here now to, let's say, 2, 3, 0.1. I'm just altering these values. 2, 12, 2.1, 0.05, 3.3, 1, 2, 0.005, 12. I'm just altering the value so that you can see what happened to the output: 0.5, 0.56, 0.7, 0.8, 1.3. Now, assuming this becomes the data, let's rerun that ANOVA test and see what happens. Remember, this OGB3 has been altered greatly and it's no longer in line with the other parameters. I'm going to still use the values to adjust maybe just another parameter so that it will be obvious that the data has been altered. Okay, now let's say we have this. Now let's go again from data. You click on analyze data, ANOVA single factor. Of course, the range is still selected, but you can go ahead and change it if you want to consider. I can just run the analysis between OGB 1, 2, and 3, of course. So I'm just running it again. Let's see what the output becomes now. Okay, as you can see, it has improved. Remember the previous results? This was 0.4. Right now, it has improved to about 1.8. And the p-value is almost insignificant here. See, this is 0.07. It's close to 0.05. Now, what if I just want to run this ANOVA test on 1, 2, and 3 only? So I'm going to select OGB1 to OGB3 just to find out if there's a significant difference between these 3 samples here. And okay. And yes, please, you can see. Okay. Slightly close. F calculated is 0.09 and F critical is 3.09. This is 3.1. That's close. You can see the p-value. This is just 0.05. I can still maybe make some alterations and see. Okay, moving on. We still have another data down here. You can see this data here. This another one. This is comparing customer satisfaction across 3 service outlets of a company. Okay, maybe let's talk about company like a fast food like Kilimanjaro or Genesis. And this is like a survey, and these parameters were collected about customer satisfaction. You can see outlet 1, 2, and 3. Outlet 3 seems to be very low as compared to 1 and 2. So let's compare and test if there's significant difference in the satisfaction level between customers at these 3 different branches. Such surveys help companies with policy control and all of that. Yeah. So from data, we'll go to analysis, still ANOVA single factor. Now I'm going to come down here and select this range of data for outlet 1 to outlet 3. Every other thing stays the same, and okay. All right, I think we have a very fantastic result here. Obviously, you can see that the F calculated is 140.55, while the F critical is 3.2. So this is a significant ANOVA result, showing that indeed there is a significant difference between at least one of the data points is falling short. And you can see that from the sum here. Can you see the mean values? First 2 recorded mean of about 82, while this one is about 36. So showing that there is significant difference. Now look at the p-value. P-value is 9.81 times exponential of minus 18. This is like 0.000000001. So it is highly significant. And you can now come back here and check. You observe that the difference lies between 1 and 3 or 2 and 3. When we get to t-test, we'll come back to these results to find out. Now we've seen that there's a significant difference. It should be able to tell us where the difference lies. Is it between outlet 1 and outlet 2, or outlet 2 and outlet 3? All right, there's going to be like 3 different cases here: 1 and 2, 1 and 3, and then 2 and 3. We'll definitely find out where that difference lies. All right. Now we have another set of data here. You can also conduct analysis of variance for 2-way. Maybe we are looking at observation. Is there difference between the observation points and also the regions being compared? That will take us to 2-way ANOVA. How do we do that? Still from data, click on data analysis. Oh, clicked on solve now. So data analysis. Now I'm going to choose ANOVA 2-factor without replication. And now my range, I'm going to select, I will select the whole range. Now remember, I'm highlighting the entire data, both the observation and the region. Now, yes, there should be label and my alpha level stays, and okay. Now, you see, there's going to be both row analysis and column analysis. That's what you can see trying to analyze count and the region. Now, for the rows, what are the data? The rows are the observation points. This thing could be different with 1 to the 5. Then these are different with 10. So in the rows, you can see the F calculated is 0.13 and the F is 3.2, showing that there is no significant difference between them. So if those were to be weeks, there is no difference when you look at it from the week analysis. Now look at the column. Column represents the week, and you can see the F calculated is 48.36 as against the F critical of 3.4. Well, you only have to look at the F when you have the p-value. Look at the first p-value, 0.9. That is, remember, I had said your p-value is significant when it is less than 0.05. That is when you say there is difference. Okay. The null hypothesis will always state that there is no difference. I hope I'm making sense to non-statisticians, but just pay attention, you get this. All right. So in the second case, you see the p-value has now reduced so much to 5.63 exponential of -7. Whenever I have this exponential of a negative number, it means it is reducing, okay? Because the negative number is like 1 over that number, okay? So this one is significant. It means that there is a significant difference between the regions, but not within the observation points like weeks. All right. So this is a significant ANOVA result here. We'll be learning how to write detailed discussion in our next class. Now look at this other data here also. This one is continuous stable frequency of Nigerian crude oil price by market period 2010 to 2025. So we can also use ANOVA to compare and check if there's significant difference between the prices. You can see when the price was less than $50, less than 75, less than 100, and now greater than 100. Compare if there is difference between the oil price. And also we want to look at market periods. We're looking at time intervals between 2010 to 2012, 13 to 15, up to 22 to 25. Okay. Now we subject that to two ways ANOVA again, from analysis, two-way ANOVA. Remember, I have to change this range to this place now. I will highlight the entire data. Every other thing is intact. There should be label, of course, and okay. Now this is the output. Mind you, if I'm going to show something. Let's just get to it now. You can see the rows. The rows are different time intervals, and it's telling us here that there is no significant difference because the F calculated is 0. See, it's perfect here. But for the columns also, this result is also showing that there is no significant difference because this p-value is greater than 0.05. All right. So what I wanted to explain is before you conduct this analysis, you have to make sure that your data points are okay. So you have to clean your data. For instance, if this place here is, let's say A or B, for instance, just one data point changed. See what happens when you try to conduct such tests, because while practicing, some persons may encounter this challenge. Okay, the same range is selected. But remember, I've changed the data point from numbers to B. If I click on OK, Excel is going to give me a warning. ANOVA two-factor without replication. Input range contains non-numeric data. So whenever I have this kind of prompt, all you have to do is just go back and investigate your data very well. You should be able to find a particular data point that was wrongly entered and perhaps correct it. I don't know what was there. Okay, it was 20. Yeah. So if you now run it, it's going to be possible. Okay. So that is it for analysis of variance. We've been able to discuss one-way ANOVA that just compares maybe a row or a column. Okay. You can also carry out that ANOVA on the parameters here. Okay. That way, let's say if I want to do that now, I'll click on analysis of variance. That's one way. Okay. Now, I'm going to select this way. And this time around now, my label is going to be row, not column, so that the first column becomes my label. Okay? And okay. Yeah, you can see that this time around now, the analysis is based on these physicochemical parameters and not the sampling stations, okay? But this one is not a very good analysis. Of course, you can see that there is a big significant difference between the performance of each of these parameters as the p-value is very small. All right, so the next we want to look at is t-test, which is also close to ANOVA. So while ANOVA tries to compare 3 or more sample points to find out if there's a difference between them, t-test can only handle 2 at a time. So it's just a pair test, okay? For instance, what we have here now have weight before and weight after. Then somebody wants to find out if there's a significant difference between weight before and weight after. Maybe somebody was on a diet or people on diets and then their weights were collected before. And then after they've completed the diet and they try to measure their weight again, now you want to test if that diet was really effective or not. So whenever you're comparing two samples, maybe sales from shop A and shop B, you want to compare sales within a month. As long as it's just two samples, you subject it to what we call t-tests. Sometimes it is also called student t-tests. So t-test is simply a test for test of hypothesis involving two samples. And that thing is important to note about t-test is usually for small samples. And in statistics, a sample is small if the sample size is less than 30, okay? If the sample size is greater than 30, t-test can also handle it, but then it is then called z-test, what Americans will call z-test. So when the sample point is greater than 30, it is considered as z-test, but when it's less than 30, it is considered as t-test. But right here in Excel, generally it is called t-test. All right. So how do you compute that? Every form of statistical analysis is done from this data analysis tool box here. So I'll click on this. I'll just press T on my keyboard. You see, t-test paired two samples. Yes. You can also use t-test to compare just one sample, maybe measured values against a proposed mean, but it's best for two samples. So two paired samples. All right, so I will highlight the first sample here. You can see the box variable 1 range. Then for variable 2 range, you highlight the second data. Now the next is asking you, what is the hypothesized mean? Remember, we are saying that there is no difference between them. So it means that their mean are equal. So the hypothesized mean difference is 0. Mean difference being 0 means that the mean are equal. Then yeah, there should be label and it should be on the new worksheet and okay. Now this is the result of the paired test. Let me expand the columns. Now, this is the result of the paired test. It's showing you the mean. You can see the mean of the first one and the second one. Now, quickly, if you come down here, you see the t-test itself. Now, look at the two t-tests. You can see the p-value is 3.07 exponential negative 12. This is significant, okay? So this is a significant test because the p-value is less than 0.05. And what does it imply to the data? It simply means that there is a significant difference between the weights of these individuals as measured before weights and after weights, okay? So that is for t-test. Now, moving on, we can also apply it to sales. You can see sales for a company between branch A and branch B. We want to find out if there is a significant difference in the sales of these two at these two branches for this particular product. Maybe these are in different months. Maybe these are total sales, okay? Just to find out if the two branches are all doing same or one is doing better than the other. All right. So if you come here and apply t-tests, the same paired two samples. Now, my input range, I'm going to input this branch A. And of course, branch B. Everything is okay and okay. Now, this is the paired t-test. Now, check the p-value for two-tail. It's always important to check p-value for two-tail. This is 2.59 exponential of negative 7. This is a significant test. All right. So it means that there is significant difference between branch A and branch B. Now, which branch is doing better? You come and check from the mean. Branch A has a mean of 124.1. Branch B has a mean of 139.6. So branch B is doing better as compared to branch A. That's what t-test tries to tell us, okay? And you can see that by the significant two-tailed test, okay? This is the t-statistics is negative, but our interest is in the p-value, which is significant, highly significant, because it is less than 0.01. In statistics, when a test p-value is less than 0.05, it is said to be significant. But if it is less than 0.01, it is said to be highly significant. All right. Now, back to where we started again, ANOVA. Remember, we tried to compare these variables. Okay, I'm going to use this one. When we checked for this athlete 1 to athlete 3, we discovered that the test was significant. Now, that was ANOVA comparing 3. Now, we are going to use t-test to compare pairs to find out where that significance lies. So I'm going to compare first athlete 1 and athlete 2 to see if there's significant difference between both of them. So I'll go again, data analysis, paired sample t-test. So my variable 1 is athlete 1. And my variable 2, I'm going to use athlete 2. Okay, everything is okay and okay. Now look at the outputs. Obviously, I know what it was going to be. Look at the two-tailed test. This is not significant. 0.7 is not significant at all. So there is no significance between athlete 1 and athlete 2. You can see their mean. This is 82.30, this is 82.7. They're almost the same. So statistically speaking, there is no difference in athlete 1 and athlete 2. But now let's compare between athlete 1 and athlete 3. We'll go back again to our analysis. Still pair test. So athlete 1 stays. Now I'm going to check the variable 2 to athlete 3. And then, okay. This is now significant, as you can see. Look at the p-value here. This is 0.72. Look at the previous p-value. It was 0.78. Okay, this is greater than 0.05. But in this case, between athlete 1 and athlete 3, you can see 0.78 exponential of 0.9. So this is significant. So there's a significant difference between athlete A and athlete C. Of course, if you look at the mean, you find out that athlete A has a very higher mean as compared to athlete 3. So why ANOVA tries to compare to find out there's a significant relationship between 3 or more samples, t-test will come in to show you where exactly that significant lies. If ANOVA is significant, t-test will now show you which pair, where does the significance lie, okay? So that is it in our discussion tonight. We've been able to advance our knowledge in statistical analysis here in Microsoft Excel by looking at analysis of variance that compares 3 or more variables to find out if there is relationship between them or not. I'm talking about significant relationship, okay? I mean significant difference, okay? ANOVA measures difference between sample points. Are they different? Is the performance of borehole 1 different from performance of borehole 2, different from performance of borehole 3, won't be compared to the standard WHO value. So this value here serves as control. In statistics, we call this value control because every other value is going to be subject to the performance of that value. So that is the control variable. All right. Now, away from analysis of variance, we've looked at one factor ANOVA, where you're just looking at one category, maybe row-wise or column-wise. We've also looked at two-way ANOVA, where you're now looking at maybe both row-wise and column-wise. These are region and these are time points. To find out the significant difference between the region and the time point, that will give us two-way ANOVA. Remember, we use two-way ANOVA without replication. All right. So after that, we looked at t-test. Of course, t-test compares just two samples to find out if there's significant difference in their mean or not. Remember, we said if the p-value is less than 0.05, it means there is significant difference. And it also means that the test is significant. And if the p-value is greater than 0.05, it means that there is no difference and the test is not significant. All right, so that is it for tonight. I'm going to open the channel now. Do you have question? Are you